Okay, so here, we are considering this finite square well, but in this case, we are sending the particle with the energy being higher than any of the potential barrier. Okay, so in this case, we solve the Schrödinger equation, and you can obtain the reflection and transmission. And then if you obtain the transmission, this has the relationship like that. Okay, and then if you plot this transmission as a function of energy, the plot is shown like this. Okay, and then what's interesting here, again, as I discussed yesterday, actually, even though the particle energy is higher, transmission is not always 1. Okay, I mean, for the bulk scale object, you would expect transmission being 1, like for all the cases, right? But in this case, there is some reflection, okay, even though the energy being higher. And also another part is that, at some point transmission hits 1, okay, 100%, but if we push that energy of the particle higher, transmission is gonna go lower than 100%, and then, it goes back to 1 and comes down and goes back up to 1, and then it kind of oscillates. But if we push the energy really high, that means it asymptotically approaches to 100%. Okay, so if the energy is extremely high, that means this particle will be transmitted like 100%, just like bulk scale, object you would expect. Okay, so in this case, we want to know when the transmission becomes 100%. Okay. So for this one, it's kind of we can easily obtain that because you look at this transmission equation. So when are we gonna have 1? That is essentially when we have this term being 0, right? And then the only way you can make a 0 is sine square. Okay. So in this case, transmission will be 1 when transmission or this sine square term. This one, sine square term here, this term 0. Right? This one. So when this term is 0, that means, this part is 0, transmission will be 1. Okay? So then, we solve this part. And then if we do that, that is 2a over h bar square root 2m e plus u naught equals n pi. Okay? So in this case, n can be 1, 2, 3, and so on. Okay? It must be integers. Okay? So if we rearrange this one, e plus u naught is simply n square pi square h bar square over 2m 2a square. Okay, again, n is 1, 2, 3. Okay. So when we have this condition, we are gonna have perfect transmission, right? 100%. Okay. So does this equation look familiar? What is that? That one was the energy levels for infinite potential well. Do you remember? Okay. I mean, you can kind of go back and double check. It turns out this is the energy levels we obtain for infinite potential well. Okay. So in this case, we are looking at finite square well, but somehow this one is also related to infinite potential well. Okay. So again, when we have available energy states or levels for infinite potential well, it just so happens that transmission becomes 100%. Okay? So again, in this case, transmission is 1, or that means 100% transmission. E plus U naught. Okay, what is E plus U naught? Do you remember? That one was energy difference between the particle energy and the bottom of the well, right? So then E plus U naught is essentially this one. Okay, this is E plus, or this one is more like E minus U naught. So this is essentially E plus U naught. Okay. So when this E plus U naught is the allowed energy level for the infinite potential well. Okay. And then for any other energies, for any other E plus U naught, transmission is not 1. Okay, there will be some reflection, right? There will be some reflection. Okay. So when the wave is sent, some wave will be reflected back, and then some will be transmitted. Okay. Okay. So do you have any questions on this? And then we are going to actually look at some